If a object have mass m and it's moving at a velocity v, then the product of the mass and velocity is called momentum. It's a vector quantity which gives us the direction and magnitude both. This equation we use for a single particle system, but if a system has multiple particles, we just add the momentum of each particle present in the system. But what if a particle is moving in a three-dimensional space? Then we calculate the velocity of that particle in xyz axis, which give us the momentum of that body in all axes. Then we add the all momentum to calculate the final momentum. And if there are multiple particles moving at a three-dimensional space, then we calculate the momentum of all particles in every axis by using this equation. Let me explain this formula to you. Here this means the momentum of every particle moving in three-dimensional space at x-axis. Let's look into that one particle in this 3D system. This particle is moving in three-dimensional space, changing its position from A to B. While changing its position, the particle has velocities in all axes. Similarly, the other particle moving at the 3D space also have velocities in all axes. Now we add the all velocities of x-axis for all the particles moving at the 3D space for calculating the momentum of all particles in x-axis. Similarly, we do it for y and z-axis. Then we add the all momentum to calculate the combined momentum of the system. Now let's talk about the relation between momentum and force. If a force F is applied to a particle and applied for a time interval delta t, then the momentum of that particle changes by delta p, which is called impulse, denoted by J. From this equation, we say that the rate of change of momentum is equal to the instantaneous force applied. From this expression, we describe the nature of the Newton's second law, where P is replaced by mv, and then we write this expression where dv by dt is acceleration, then we write F is equal to ma. If two body is moving towards each other in a closed system and both body are collided, then the final and initial momentum is same, which is called law of conservation of momentum.